Welcome back to day 2 of Linux Basics for Hackers from Hackers Arise. As you know, I'm OTW, and in today's class, we're going to cover the next, 6 or so chapters of Linux Basics for Hackers. So we left off, we were looking at process management in chapter 6. So today we'll try to cover managing user environment variables, bash scripting, compressing and archiving, file system and storage device management, and the logging system. I think that will probably take us through today's class. Maybe we'll get to using and abusing services. But before we do that, let's start off with the managing the user environment variables, or chapter 7 from my book, Linux Basics for Hackers. The environment variables in Linux help to manage the environment that you're working in. The environment variables technically are broken up into two types of variables: the shell variables and the environment variables. Environment variables are the process-wide variables built into your system and interface that control the way your system looks, acts, and feels to the user, and they are inherited by any child shells or processes. Shell variables, on the other hand, are typically used in lowercase, typically listed in lowercase, and are only valid in the shell that they're set in. All right, so let's go ahead and let's move into our Kali. Let's take a look at our environment variables. All right, let's log in as Kali and open up a terminal here. Let's wait for it to boot up. Come on, Kali. Okay, now we're logged into Kali. Got a terminal open. Let's go ahead now and take a look at some of our environment variables. The first command that we need is the env command. Okay, env stands for environment. Let's go env, and when I hit enter, you'll see I get a whole lot. All right. So you can see some of the environment variables, for instance, are the shell. Well, it defines it as bin bash right there. Okay. Other key variables here, there's an awful lot of variables. Here's our present working directory. Okay. The log name is Kali. Notice these are all in caps. Okay. They're all in caps. Our home is home Kali. The language is English and UTF-8. What else do we have here? Here's the user Kali. These are some colors that are set to display here. And a lot of other variables. Okay. If we want to see all of the user variables, including the shell variables, local variables, and shell functions, we can use the set command. Let's try the set, and we get a lot. See, just displays it all, similar to what we do with cat. So this be a little more useful. Let's try using the more command. All right, and there we get something that's more useful, and we can see. Notice that they're all in uppercase. All right, they're all in uppercase. Notice that here we have his size, and we're going to talk about that in just a minute. We'll be using that in just a minute. His size is the number of commands that Kali stores in your history. All right. So let's go through. I'm just hitting enter, going through and looking at all of the lines. You can see they're very similar initially to what we got in the environment, but then we get even more. All right. Even more variables, because now we have both the shell, the environment, and some functions. And then, like anything in more, to end it, we can just go and see, use the Q and come back to our Kali prompt. All right. So we've got all these variables. What if we just wanted to find one? All right. So we can use our grep. We learned grep a little earlier. We can go set and then grep and look for a particular variable, in this case, the his size that we were talking about. Let's go his size. And you see there it is. His size is set to 1,000 commands. What if we wanted to change that? So for instance, what if we wanted to change the his size to 0 so that when our commands, our past commands, are not stored? So when I hit up arrow, right, I hit up arrow, see all my previous commands, down arrow, right? All my previous commands are stored there. Now, maybe I don't want those to be stored for whatever reason. Somebody else is using the computer. Maybe I want to cover my tracks. One of the things I can do is to change the his size. All right. So we could do that by going hist size is equal to 0. Notice it's all caps. Hit enter. And now, if we go ahead and up arrow and down arrow, nothing happens. All right. My history size is 0. Nothing's being captured. If I want to go ahead and set it back, I can go hist size is equal to 1,000. All right. And now if I go set, pipe it through grep, hist size, you can see it's set to 1,000. And then if I hit up arrow, you can see my commands are being stored again. All right. Now, the way things are set up in Kali is that when I change the his size, it's only for that particular environment. Okay. If I want to go ahead and send it out to all the environments, okay, all my shells, I can go and say export, right, his size. Now this will send it out to all the shells. Okay, they'll all be set to 1,000. I can also change the prompt on my system. So let's say, let's go once again, go set grep. In this case, we're looking for PS1. And you see that there's an entire script here just to change the prompt. Okay, we're not going to change it here. What I'll do is I'll address it in the revision of this book and how we can go ahead and change it. People have written to me and saying they've changed the prompt and they're not happy about it. How can they go ahead and set it back? So we're not going to do that here. We'll just keep on moving along. We're doing some things that are probably more important to your using of Linux rather than simply changing the prompt. The way that the default prompt in Kali works pretty well. All right. In other words, it's telling you what the system is and the user. Right. If we go ahead and change directories, so change directories to Etsy, right? You can see it tells me what directory I'm in. Okay. If I'm in the root directory, okay, you see I'm in the root directory right there. So it works pretty good. All right. So let's not change that. But maybe something we might want to change is the path. That's something that has leads to sometimes easier work in Kali and in Linux in general. So let's go ahead and just use the echo command. Okay, echo command simply shows you the value of a particular variable. Okay, actually, its echo can be used to display anything on the screen, right? In this case, what we're doing is using echo to display the contents of a variable. And to get the contents of a variable, we need to use the $sign and then the name of the variable, in this case, path. Now let's take a look at this. Now you may not have seen this before. If you have, great. It applies to almost all operating systems, Windows and Mac and Linux, Unix. But basically, this is the area where your system looks for the commands that you enter at the command line. So when I enter echo, for instance, okay, it looks here, user local bin for it. If it's there, it executes it. If it's not there, it then goes on to user bin. If it's there, it goes ahead and executes. If it's not there, it goes to the bin directory. If it's not there, as you get the idea, it goes through each one of these. And if it doesn't find it in any of these directories, then it comes back and says command not found. Right? So even if a command is, so for instance, you put a new tool in and you're trying to execute it, if that tool is not in one of these directories here, it's not going to find that command, okay, that script, for instance. So what you would need to do is you would need to append your path command if you want to be able to run it from any command prompt anywhere on your system. So it doesn't matter what directory you're in, it'll go to these directories looking for that command. So if we have, say, a new tool, and say we want to go ahead and add it, all right, to our path command. This is the way we do it. We can simply go the name of the variable, path, right, and then set it equal. And now what we need to do is to use the value, okay, $path. So that says set the path equal to the value in path, the current value, okay, so we're duplicating it, and then colon, add root, and whatever the hacking tool might be, all right? So now what this will do is it'll alter the path to include the directory where our new hacking tool's at. Hit enter, and now we can go ahead and go echo path, and we should reflect the new path. And you can see there it is there. All right. So if there's a script or another tool that's in that directory, it'll automatically look in there for it. Okay. It'll look in these other places first, which leave those pretty much the way they are. All right. Then moving on. What if we wanted to create our own variable? Right? We can create our own variable in Linux. Let's go ahead and just create a variable, my new variable. My new variable is, and then I put a script or some string in there. The string is going to be something you've heard from me many times. Hacking is the most important skill set in the 21st century. And let's put double quotation marks around it, not single quotation marks. And then hit enter. All right. And now if we go ahead and say echo my new variable. See, what I did is I simply echoed the name of the variable and not the value inside the variable, which is what I want to do. So I got to put the $ before it. Okay, go up arrow. All right, and then put the $ before it, and then hit enter. There we go. So there's the value inside of that variable. Of course, it could be a numeric value. It could be a script in there. All right. So if we wanted to go ahead and unset that variable, unset my new variable, okay, unset it, and then we go ahead and echo. Once again, make sure the $ is before it. My new variable, and we'll see there's nothing in it. All right. So as a quick and dirty lesson on using environment variables, I'll probably spend some more time on environment variables in Linux Basics for Hackers 2. Right? We're going to go into a little more depth in that one. But for now, I think you have everything that you need to be able to operate and function within any Linux environments and have a basic understanding of the environment variables. All right, let's move on to Chapter 8 then. Chapter 8 is an important chapter. This was on bash scripting. So as I say in this chapter, any self-respecting hacker has to be able to write scripts, right? You need to be able to run some automated scripts to do a particular task, whether it just be, running through and doing something over and over again, an administrative task or a hacking task. You need to be able to write some basic scripts, okay? So if you want to become an elite hacker, you probably should have skills in Python as well as in the bash script. Maybe even some Ruby or some Perl. All of those are available at Hackers Arise. I also have a class called Python Basics for Hackers, which you might be interested in. It's part of the subscriber package, and another course called Scripting Basics for Hackers, which covers the basics of Python, Perl, and bash scripting. But what we're going to do here is we're going to create some simple scripts, all right? And we're going to use a text editor. This is Kali 2023, as you can see it right up here, right? 2023. And the default GUI-based text editor is Mousepad. I'm not going to force you to learn how to use Vim. All right, let's go ahead and use one of these GUI-based text editors. Maybe we'll spend some time on Vim in a future tutorial. But what we're going to do here is we're going to create some basic scripts. Now, to run a script, basically what you need to do is simply put the commands that you want to run into a text editor, save it, give yourself execute permissions, and then run it. All right, so let's go ahead and do that. So we got to start off with what's called the shebang. Okay, shebang basically tells the interpreter which tells the system which interpreter it should use. In our case, we want to use the bin bash interpreter. Interpreter is simply a tool for being able to make sense of the commands that you're running. So if you're running Python commands, use the Python interpreter. Okay, those will make some sense of. They understand Python commands. If you're running a bash script, then you need to go to the bash interpreter because it understands bash commands. There's no universal interpreter. All right, you got to tell it. The first thing you do when you're writing a script is tell it, what interpreter should I use for this? All right. Now, the first thing you're writing any script is you got to know that the pound sign is for comments. All right. Pound sign says everything that follows on this line is a comment. It means don't send it to the interpreter. Don't try to run it as a command. All right, so we can use the pound, and that is the next line. Everything that follows this line is a comment. It's simply strings to be read by the developer or other people who are working with the script. So we can go ahead and just put a quick comment in here and say, this is my first bash script. All right. So this will be read by the interpreter. Okay. Then this will not be read by the interpreter. And then we're going to put in a simple echo. Okay. Which is something that'll go ahead and print something out on the screen for us. And typically, when people are doing their first scripting or programming, it's always hello world. But in our case, ours is going to be a little different. It's going to be hello, Hackers Arise. Hello. Good to see you. All right, we've got to put an exclamation point in there. All right, something like that. And then what we can do is to save that. Let's save it as save and we're going to put it into, let's put it into our home Kali, okay, home Kali directory. I'm going to call it first script, okay, .sh, which says, basically sh says that it's a bash script, right? That's all it says. It doesn't, those extensions in Linux really don't carry any weight. It's simply something for you to be able to recognize what it is. So let's go ahead and hit enter and save it. Okay. Notice that immediately, now that it knows it's a script, it uses some color coding. Okay. The echo is in red. This is all in blue. The string is all in green. So let's go see if we can run this. All right. Go ahead and close this. And now, first thing we need to do before we run it is go ls-l. First of all, we need to go into that directory. Go cd home Kali. You may already be there. I'm not. Okay. And then do ls-l. And we should be able to find that script. Where is it? First script right there. Okay. Now, earlier we learned about permissions on files, and you can see that Kali, the Kali user, has read and write permission. The Kali group has read permission. Everyone else has read permission on it, but nobody has execute permission on it. So we've got to change that. Earlier, we learned that we could change the permissions, okay, using the chmod command. Change chmod, chmod, and let's say 755. That's going to give everybody, 755 means that everybody's going to get permission to execute. All right, and then we're going to go, it's called first script, right? Is that what the name of that? First script SHA. Now, if we do an ls-l and go back to that file, we'll see that, first of all, it's changed color. It's now like a greenish blue. And we can see that the user, the owner, the group, and everybody else can execute that script. All right. So we're giving everybody permission. So here you can see this is RWX. That's 421. That's 7. R-X, that's 4 and 1, that's 5, and same with everyone else. That's where the chmod 755 comes from. All right. Now we can go ahead and execute this script. All right. So we can, first of all, let's just try running it first. Let's use the sudo first script .sh and hit enter. And you can see that it comes back as command not found. This takes us back to what I was telling you a minute ago about the path command. When you run a command, it looks in those directories that are in the path command for that particular script or file. Now, in our case, ours is in the home Kali directory. So it won't look there. It's not in the path command. Let's go back to our path command. Echo, even though we changed it, echo path, you can see that the home Kali is not in that path command. There's not a directory in there. So it's going ahead, and we try to run this. It looks in each of these directories. It doesn't find it and says command not found. Now, to run this script, what we can do is that we can tell Linux that we want to just look in the current directory. And we can do that by using a ./ and then go first script sh, and you can see it ran. All right. So now when we put that ./ before the name of the script, it doesn't go to the path command. It goes into the directory that we're working in, the present working directory, and looks for first script there. All right, and we were able to run our script quickly and easily. All right, so let's go ahead and create let's create another script. Let's go ahead and open up Mousepad again. Sudo Mousepad. And now in this case, we're going to create a slightly different script. This is a script that has some historical significance within, within the hacking field. It was used by a fellow by the name of Max Butler. This is back in the first decade of the 21st century. I called it aughts. Okay. And he was a gray hat hacker who, during the day, was a security engineer for a Silicon Valley company. And by night, he was hacking and running the world's largest Carter market. His name is Max Butler. And one of the things that Max found out was that he could go ahead, that there was these point of sale systems run by small restaurants called the Aloha system that had port 5505 open so that the tech support could come in and help small business owners who were running their software. And so when somebody connected to port 5505, there was no authentication, and they went in and they had basically root privileges over the system. So what Max figured out is that he could go in to these port 5505, extract all the credit card numbers and names, and make a fortune. And he did. Before he got caught, he's scheduled actually to be leaving prison. I think this month. This is April of 2021. He's been in prison for like 13 or 14 years, and he's scheduled to leave prison now. But here's something that he did. He let run at night to find machines that had port 5505 open. Okay. Okay, here's what we got to do. First of all, like any script, we're going to go use the shebang and then tell it go bin bash. Okay, that's where we start. And then we're going to put in a little comment here. Okay, this script is designed to find systems with port 5505 open. Okay? And then all we're going to do is create a nmap script that's going to search for port 5505 open. So if you know a little bit of nmap, okay, if you don't, I have a couple of tutorials on Hackers Arise on using nmap, but nmap just goes out and finds out whether or not ports are open. So what we're going to do is create this script and have it look for port 5505. And let's go and, let's see. Before we do that, let's open up another system that we can test it on. All right. So first of all, let's see if we have, let's ping Google, see if we can access the outside world. We can't. All right, let's go to network, go to settings. Okay, it's a bridge adapter, that's fine. So let's go ahead and open up another machine on this system, on this virtual box. And let's go here. We've got several machines. Let's just open up Metasploitable 2 just for fun. Okay. And open this up. Okay. Oh, this one doesn't work. Let's go open up a different system. Let's go here. And I got several of them. Let's go to the OWASP BWA. All right, let's open up this one. And then let's use this as our target system. You can use any system. We're just testing on a script, right? So we'll use this as our target. All right. Just take a minute here. I'm going to close this one down. This one should be just about up and running. Let's log in as root. and is OWASP BWA. Okay, there we go. So here's our OWASP machine up and running. And let's go ifconfig to see what IP address it has. And it looks like it doesn't have any IP address. That's a problem. And, all right, just trying to get my mouse back. All right, let's go over here and see what IP address we have on our Kali system. And I gotta go sudo ifconfig. And this one doesn't have an IP address either. So we're gonna do a little assigning of IP addresses. All right, sudo ifconfig. All right, ETH0. Let's use some real simple IP addresses. 1101. All right, then go sudo ifconfig. And you can see it now has 101. Then let's go back to our BWA system. And let's get it up over here. And let's assign it. Now, it doesn't require sudo to use. We're logged in as root. We don't need to use sudo to get privileges there. So we'll go ETH0, 192.168.1.102. Okay. And now we should be able to ping these machines. Let's go ping. And go 192.168.1.101. And there, we've got connectivity. Beautiful. Okay. All right. Let's go ahead and minimize this system. All right. And then let's go back to our, let's make sure we can ping both directions. Okay, 192.168.1.102, I believe that one was. Yep. Okay, good. All right. Now, let's just do a quick demo on Nmap in case you're not familiar with it. Let's go sudo nmap -st 192.168.1.102. Basically, Nmap's going to go out and try to do a three-way handshake to each of the ports on that system and see whether or not they're open. Let's go ahead and run it. Just should take a moment here. Should come back with our report. And there we go. You can see it shows me these ports are open. All right. SSH on port 22, port 80, 139, 143, 443, 445. They're all open. 5001, 8080, 8081. All right. Those are all open on that system. So that's what Nmap can do. What we want to do is to go and create a script that's going to look for a particular port. In this case, it was Max Butler was looking for port 5505. And so we're going to go out there and go 192.168.1.102, okay, looking for -P 5505, right? And then we're going to send it to dev null. So that's sending the output that normally appears on the screen to dev null, which is basically sending it to so it doesn't appear on the screen. That's what it does. And then we're going to send the output in a greppable format, okay, to, let's call it Aloha Scan. That's the name of the file. And then we're going to display the contents of that scan, Aloha Scan. I've got to make sure my case is correct. Okay, it should be uppercase A, Aloha Scan. And then we're going to use our grep command to find just those lines where there's an open appears. All right? Looking for the word open, and then send it to another, type it to another file called Aloha Scan 2. All right? And then we're going to cat that file, Aloha Scan 2. Okay, let's go through this then. All right. So here's our bin bash, tells it what interpreter to use. Okay. Then we have the comments, okay, right here. So it's not going to be executed. Then we're going to have run the nmap command against this particular system, looking for port 5505 is open. Send the output that normally appears on the screen to dev null. That's just a place in Linux where things disappear. Okay, and then we're going to send it in a greppable format to a file called Aloha Scan. And then we're going to display cat Aloha Scan and then pipe it to grep, looking for the keyword open. Okay, what we're looking for is that keyword open. We saw it earlier right here, this keyword here, open. We only want to see those lines where that appears, and then send that, okay, redirect. That's what that is, sends that output to a file called Aloha Scan, and then go ahead and display that file. And then let's go ahead and save it. All right, save that file. And we'll save it once again in Kali. We'll call it Aloha Scan.sh. All right. You see that the color has changed on our script. Let's go over here and let's take a look and see if we can find it. All right. Whoops. ls-l. And it should be right near the beginning. There's Aloha Scan. Notice we don't have any execute permissions on it. So let's go ahead and fix that. So we're going to go sudo, okay, chmod 755. Actually, let's do 744. That means only the owner is going to have execute permissions on it. And for Aloha Scan sh. All right. Now, if we go back to our file, let's take a look at it. And we should see that once it changed colors, we can see now that we have the X there, so we can execute it. Nobody else can execute it, though, just us. And then let's go ahead and run it. And hopefully we don't get any errors. Let's go. But that's part of the learning process to get errors. All right, so let's go ahead like this. This says go and look in the current present working directory for Aloha Scan, and if it is, run it. Let's hit enter, and permission denied. Permission denied. Let's go sudo Aloha Scan. There we go. And what it's doing now is it's running that script, looking for what ports are open on that system. And you see that it came back with nothing, because we know that there are no, that port 5505 is not open on that system. All right, so for demonstration purposes, since we know what ports are open on that system, see if our script works, we know that there's, for instance, this port 8080 is open on that system. Let's do that. So let's change our script to look for that port and see whether or not it works. Let's go ahead and save it. All right. Let's try it again. Let's see whether or not it works looking for port 8080. Ultimately, we'd like to use this script to scan the whole world for port 5505 open. That's what Max Butler did. But as we're testing it, we just need to make sure that it works. So we're using it on a test system here. And let's go ahead and hit enter and see if it can find port 8080. There it is. Beautiful. Okay. So it went through and grabbed the single line of output where it said open. Right. It didn't show me all of the output that we normally would get, right? We got that, we ran it before, we got all of that output that showed all the ports that were open, right? But we were only looking for port 8080. It found that it was open and gave us that in our single line of output and sent it out to a file called Aloha Scan 2. So we could go cat now, Aloha Scan 2, and you can see we get the same output right there. All right, let's go ahead then and make some changes to our script. Now, our script right now only allows us to be able to scan for one IP address and one port. What if we wanted to make it a little bit more flexible so that it could scan multiple IP addresses and maybe a range of IP addresses and different ports? So we can make this kind of a generic scanner that can go out there and look for ranges of IPs for certain ports that might be vulnerable to attack. Let's see what we can do to make that happen. So let's go ahead and change. Let's leave our comment the same. But what we're going to do now is we're going to send out an echo like we did earlier, right? We did the hello hackers arise. But so this is what's going to appear on the screen to the user. So once again, we're trying to make this more of a generic script that has greater flexibility, can look at different IP addresses, different ports. So what we're going to do is we're going to prompt the user enter the starting IP, okay, that they want to start scanning at. The starting IP address to scan, let's say. All right. And then close it with so we put it all between, notice it all turns green. It's all just simply strings that's going to be echoed back to the user. And then we can put in a read. Now, what read does is that it takes whatever the user inputs from the keyboard and puts it into a variable. So what we need to do is simply give that variable a name. We'll call it first IP. All right. So when the user sees this prompt, the system will stop and wait for them to put in an IP address, and it'll go into this variable called first IP. All right. Then we're going to say echo. All right. So this is going to be just what's going to be seen on the screen to the user. Echo, enter the last octet, okay, of the last IP. And the reason that has to be the last octet is that Nmap, when it looks for a range of IP addresses, will only work within a single network. And when you put in the range, well, I'll show you, okay? So when you're working Nmap, right? So you're doing an Nmap script looks like this: 192, 168, 101. If you want to put in a range, you put in a dash, and then you can put in the final octet of the range. In this case, say 255. Right? So it'll scan all the IP addresses between 101 and 255. Because it won't take a full IP address, it will not take this. Okay, it's just how Nmap works. It will not use a range that looks like this. All right, that'll throw an error. All right, see, failed to resolve this. All right, that doesn't work. But if I did, say, like this, now it works. All right, so it'll take a starting IP and then the ending octet. So let's stop it here. So that's why we have to make our scan this way. Enter the last octet of the last IP. All right. So it's prompting the user twice. All right. And then we want to prompt the user for what port they're looking for. All right. So echo, and then we'll say enter the port number. Let me get a dash in there. The port number you want to scan for. Let's put in like that. Okay. Double quotation marks. And then actually over here, we got to fix this right here because we didn't put in a variable read last, we'll call it last octet IP, like that. That goes into, this should be read. Let's get this fixed here. Okay, read, and then this should be last octet IP. Let's make sure that it, remember that Linux is case sensitive. All right, so let's get like that. And then we need to, over here, read, let's just call it port. Then, okay, so we've prompted the user 3 times for information. Okay, then we want to go ahead and put these variables into our scan. So we're going to use the first IP and the last IP and the port. Everything else pretty much should stay the same. So let's go ahead and make those changes. So rather than having a fixed IP address, we'll just use first IP. All right. And then we're going to run from first IP through the last octet IP. All right. So that says go ahead and start scanning at the IP addresses in here and run to this octet, this final octet here, looking for port 8080. But let's fix that and put in the variable port. All right. You see how this has become far more flexible. We can, the user can go ahead and put in any IPs, an IP range and port, and get it to scan. One of the things that we need to remember is that when we're using a value of a variable, we need to precede it with a $sign. All right, so these all have to have $signs before them. Notice they turn purple. All right. Now, let's go ahead and save it. I think we've got everything right. Let's go ahead and save. And we're going to call this one, let's call it Aloha Scan 2. All right, this is just to distinguish it from the other one. All right, and then let's save. Then, of course, we need to give ourselves execute permissions on it. All right, so we're going to go sudo change mod 744 in this case, Aloha Scan 2 sh. Okay, good. So now we should be able to run this. Let's take a look at it. Let's see if we can run it. Let's go sudo Aloha Scan sh. Remember, we have to precede with the ./ It says look in the present working directory, not in the path variable for this particular script. And hit enter, and it starts running. Oh, my bad. It should be Aloha Scan 2. All right, let's stop it. Control C. And what we want to do is do Aloha Scan 2. All right, and then it should start prompting us. All right, enter the starting IP address we want to scan. Okay, let's do this. 192.168.1.101. All right. It takes that and puts it into a variable. And then it says, what's the last octet of the last IP? Let's go 255. Okay. What port do we want to look for? Let's look for 8080 because we know that one's there. And then go ahead and hit enter. And then it should begin its process. Now this is going to take a few minutes. So I'm going to pause the recording and then I'll come back as soon as it's done. Okay, we're back. It only took a couple minutes and you can see, all right, that our script ran effectively, right? It ran through some 155 IP addresses, found only one of them that had port 558080 open, all right? And our script now is written flexibly enough that it can run through any range of IP addresses and look for any ports, all right? So good job. That seemed to work great. Hopefully everything was pretty clear in what we did there. Pretty simple script, but it's pretty useful at the same time. Just one of the things I want to point out is on page 9091, there's some built-in bash commands. You might want to take a look at some of those. These are commands that are built in. We can put any system commands into our bash script, but we also have some built-in bash commands as well. So take a look at that. And with that, that concludes chapter 8. And let's move on now to chapter 9. Okay, let's move on to chapter 9, compressing and archiving. When you're using Linux as a hacker or in any capacity, very often you're going to need to install or download new software. And the smaller that software is, the faster it can be downloaded. And so that's what takes us to compressing and archiving. If you come from the Windows world, you probably are familiar with the zip format. So what we're going to be doing is something very similar to that. We're going to be using multiple compression algorithms that are open source and built into Linux for being able to compress and then eventually archive some files. All right. So let's go ahead and close out some of these things that we have going on. Let's close out this mouse pad. And let's see if we can close this terminal. Let's clear this one up. One of the things that often newcomers to Linux are surprised to see is the idea of tarring files. Tarring files is basically what's called a tape archive, tape archive. So it's like this tape archive, okay? Or it's abbreviated as tar in Linux. In tar, what it does is it takes multiple files and puts them together. It doesn't necessarily compress them. Actually, it doesn't compress them. It actually makes them larger. Okay, but it puts them together so that they can be transferred as a single file. One other quick note about compression here before we move forward, and that is the idea of lossy and lossless compression. Lossy compression is what you're probably most familiar with. That's things like MP3, MP4, JPEG files. Those are all lossy compression, meaning that you can get good compression by not having the resulting file from the compression be identical to the original file. There are some losses. That's why it's called lossy compression. Let me put it up on the screen here so you can see what I'm talking about. Okay, there's lossy compression. Lossy compressions are things like MPEG, MPEG 3. I'm sorry. Yeah, it should be MP3s and MP4s. And MP4s, it actually is MPEG. All right, but we abbreviate as MP, and JPEG. Okay, these are all lossy compression. They're very efficient, but they produce, in this case, video or music or an image that's not identical to the original. You can get better compression if you actually are able to lose something. Right? So maybe the color green isn't exactly the same as the original. Right? So this is, by doing this, you can go ahead and get much better compression. Now, lossless looks like this, is where the original file and the resulting file after compression are identical. Right? This you can't get as good a you can't get as high a compression ratio. Okay, you can't compress it as much, but you have exactly the same before and after compression. All right, moving on then. Let's talk about some archive and then we'll get into some compression. Let's go ahead and let's make up some files. And we're going to look at how we can go ahead and archive them. So we're going to make, let's say, well, let's go see what I have here. Well, let's see what we can do. See some files that we can use. Let's see. You see, there's a bunch. We have all these files right here. We can go ahead and the Aloha scan. We can go ahead and tar them together. All right. So let's go ahead and do that. So let's go tar. Okay, what tar does is it takes the individual files and puts them together into a single file. All right. So we're going to go tar dash CVF. All right. And then we're going to go ahead and put each of those, the resulting file, let's call them Aloha. Let's call it Aloha archive. Let's call it that. Archive tar. And then each one of the files that we want to put in there. All right. So we go Aloha script, Aloha script 2. And we had some others there. We had just those two. Aloha scan. Let's get those straight. Aloha scan. Scan. And Aloha scan 2. And what else do we have there? And then we just have the executable files there. And let's just work with those two initially. All right. Let's go ahead and call them Aloha archive using the CVF. The C option means to create. The V stands for verbose. Almost all of the Linux commands, when you use the C, it means verbose. It means give me all the information or give me more information. All right. And then the F means to write to the following file. So we've gone create, give me verbose, and then write to the file, this one right here, these two. Let's go ahead and hit enter. And you can see it comes back and it gives me the Aloha, the two files that went into that file. Now, if I left off the V, you can see that what happens if I do it again, nothing happens. So by using the V, it gives me that output of what files are going into this archive. All right, there we go. Now if we go ls-l and take a look, we should see the Aloha archive. There it is. I went too far up. There it is right there, the tar file. Now, if I wanted to untar them, which means take them apart, all right, then I can go ahead and use the tar command, and then let's go -x, and that means extract verbose file, and then we'll call it Aloha Aloha, what was it, archive, tar. Okay, and notice it comes back, and now our archive has been untarred. All right. So that's a real common way. When you're downloading files, you'll often find that they're tarred, and you also often find that they're zipped using gzip. Okay, and that's what we're going to get to next. All right. So let's go ahead and look at compressing files. We're going to look at 3 different methods of compressing files. I'm going to put it up on the screen here. We're going to use, for instance, gzip. Gzip. We'll look at bzip 2, and we'll look at compress. As our 3 compression algorithms. Let's start with gzip. Gzip, okay, is the most commonly used compression utility in Linux, so you're going to find it a lot. Very often you'll see that at the end of a file name, you'll see that it has been zipped, where you'll see the file is going to end with a gz for gzip. So let's go ahead and try zipping those 2 files together. So, for instance, we can make things simple. We can go gzip, right? And then say aloha, right? And then let's just go anything with aloha in it using wildcard. So it says go ahead and zip anything that has starts with the word aloha, and then go ahead and take a look, and we should see it up above. And you can see that there's our gzip. So we've gone ahead and zipped the Aloha archive. We've zipped the Aloha scan. So everything that has Aloha, starting with Aloha, is now zipped, making it much smaller. All right. Let's take a look at how much smaller. So here, for instance, the Aloha archive tar is only 364 bytes. What was it before? Let's go up above and take a look. And you see it was, wow, okay, it's down to about the third the size. All right, it was 10,000 bytes. All right, and now, wow, it's significantly smaller. Oh, okay, I think that isn't a good reflection. Let's look at the Aloha scan, 391 bytes, and then down below when it's zipped, 90 bytes. Okay, so about a quarter the size. That's more typical. Let's go ahead, Aloha scan. Yeah, let's go to Aloha scan. The original one was, let's go up here, and Aloha scan was 391. That's the one I was looking for, 391. And yeah, let's start with the first one. Aloha 190 here. The script, the executable script, 190, and then the executable script dropped just by a little bit. I gotta compare apples to apples here. Then go to Aloha scan 2 is 391. There we go. And then let's go down here when it's zipped. Aloha scan 2 is 90. All right. Actually, let's go to Aloha scan right here, 262. All right. Comparing them, 262 and 391. So less than 50% compression. We want to go ahead and unzip them. It's pretty simple. Use gun zip. And let's go and say Aloha again. So we'll do using a wildcard. Everything that has Aloha, starts with Aloha, we want to unzip it. And now we can go ls-l. We should see that all of those files are now unzipped. Okay, this one is still tarred, but these are all unzipped. All right, so they're back to their original size. We can also do the same thing with bunzip. Okay, bzip. And so we're going to go bzip2. All right, let's go aloha. And we'll use the wildcard again. So we'll go ahead and zip all of them and do an ls-l. And we'll see that they have all been zipped as well. All right. And you see they all end with bz2, bunzip2. And of course, we can go ahead and unzip them by using bunzip, which I mistakenly said originally. Bunzip2, right? That's where we unzip. It's b unzip2. And then we'll go aloha. And using the wildcard again. And now we go ls-l. And we can see they've all been unzipped. All right. We still have the tar, which basically is taking multiple files and put them into a single file. That's all tar does. But these compression algorithms can be used in conjunction with the tar to make them smaller as well. And then we can also do the same thing with compress. Go aloha, aloha, and then wildcard. And now we go ls-l and go up and take a look at those. And they just end in a Z, okay? They've been compressed. And generally, the gzip is the most efficient, bunzip is second, and compress is the least efficient of the compression algorithms. So to unzip the compress, we simply do uncompress. And we'll do aloha again. Aloha. Everything with aloha starts with aloha, wildcard, and unknown suffix gzip. One of them still have gzip on it. I'm getting a strange message there. See, these all have Z at the end. All right. Aloha, unknown suffix ignored. Oh, I just ignored those. So let's go ahead. It didn't have a Z at the end, so I ignored it. Let's go back and look, and they should all be back to their original size and integrity. All right. One more thing that we want to take a look at is creating physical copies for maybe archiving of a drive. And the command that we're talking about here, let's go ahead and clear our screen, is called dd. Okay, this creates a bit by bit or physical copy of whatever drive you're trying to copy. So I'm going to go ahead and put in a thumb drive. Okay, so we can use that. It can be used on hard drives, thumb drives, any storage device in Linux. All right, I'm putting in a flash drive, and let's make sure that it's attached. Let's go up. You see it came up here, but I have to attach it then to my virtual machine. And let's go USB, and here it should be right here. It's a PNY USB 3. I want to attach it. Wait for it to come up on the screen here, then we know that it's been mounted. There it is. Okay, so DD can be used for archiving, for making bit-by-bit copies of flash drives, hard drives. In forensics, for those of you who have been through my forensics class, know that it's used to also create a forensically sound copy of a drive or any storage device. And so that's where you'll often see it. So the format for DD looks just like this. It's just going to be DD, then the input file, whatever that file happens to be, and then output. whatever that file happens to be. So it's real simple. DD input file equal, and then the name of the file, and then output file. All right. Now remember that in Linux, the name of the devices are going to be slightly different than what they are in Windows or in the Mac OS. In our case here, the devices are going to have names that, well, let's take a look at it. All right. Just so what I did is I ran df in Linux, and you see these are all of my devices, and it gives me how much they're being used, the number of blocks, how many are used, the available, and the percent used, and where it's mounted at. Notice that here's our hard drive, SDA1. All right, that's the way that Linux denotes the drives. Is that it's first of all the dev, okay, device, and then the type of device, okay. In modern systems, when you're using SATA drives, it starts with the S, and then device, and then which device. If it's the first hard drive, it'd be A, and then the second would be B, and third would be C, and then what partition of that device. So this would be the first partition of drive A. That's probably a SATA drive. So to go ahead and use our DD command, we could use this very simply. Go DD, okay, remember, it's pretty straightforward. Use the IF, all right, and then equal, and then dev SDA1, okay, that first partition, and then we could go ahead and go output file, oops, it should be OF, and then where we want to send the output file to, say root, let's call it bit copy of device. All right. We might use this, for instance, for archiving, making copies. We might also be able to use this in forensics when we want to make a physical copy of the drive, not just a backup. We will make a physical copy because physical copies can be used for forensic analysis because it includes things like deleted files, like what's called slack space, and this would be like the remnants of a file that's been overwritten. When you're making a backup of a file, those things are not included. So DD is kind of an important command. All right. So that concludes chapter 9. Let's go on. Since we're talking about file system and storage device management, let's take a look at that. Remember that in a Windows system, the hard drives that generally have the hard drives, and all your storage devices have A, B, no, A, C, D, E, F. They have letters for each physical drive. Not true in Linux. In Linux, what we have is, remember, we have root at the top of the file system, and then all of the devices are attached to it. All right. So let's go ahead and take a look at, for instance, let's go back a little bit. Let's go up to CD, up to root. That's the top of our file system. It's kind of similar to the C drive in Windows, except that the C represents a physical drive. In our case, the root represents a logical top of the file system tree, and it can have multiple physical drives beneath it. Multiple physical drives beneath it. And so every device is stored under the top of the file system. So if we go to the very top, and then we can go ahead and do, say, an ls dash, let's just do ls, we have all of our directories at the very top of the file system, including one right here that we may have mentioned earlier called dev. Dev stands for devices. That means that there's a file in this directory for every device. Let's go there and take a look at it. Let's go ls-l, and you can see there's a whole lot of files in there, right? A whole lot of files for every device. And notice here, these are the storage devices: SDA, SDA1, SDA2, SDA5, SDB, and SDB2. So there's two storage devices. All right, and we'll go into this a little bit. Two storage devices, one is A and one is B, and they have multiple partitions of those devices. And those are all the devices on the system. As I was mentioning earlier, and we did it with the dd command, in Linux, we represent Linux hard drives, or any storage device, or storage devices. They're represented this way as SDA, we saw that. Okay, then SDB would be the second storage device. SDC, okay, would be the third. And since most of us are using SATA devices, okay, or we're using solid state devices, they're all going to be represented as S. If you're using an older system that has IDE hard drives, they're going to be represented as HDA, HDB, that way. Most of us have SATA devices. They've been kind of the standard for 15 years or so. So this is probably what you're seeing on your system. And then each one of those devices can be partitioned. Like we saw below, let's go up here, we saw our storage devices were partitioned. You see here's the device, partition 1, partition 2, and then the third partition has a 5. This one is my flash drive, and it's the first partition on that flash drive. So going back here, our partitions each one of the devices can be partitioned, all right? If we wanted to see, okay, which devices are on our system, one of the things, these are all of our all devices. Okay, you're gonna find things like keyboard and mouse and floppy drives if there are any. These are all devices. These are all TTY are all the terminals. All right. Let's go back. Let's go and take a look at fdisk. Fdisk is a command for being able to list all the storage devices on your system. Let's go. I'm going to go ahead and clear my screen so you can see it better. Clear. Clear. Gotta spell it right. Clear. Wow. Twice. All right. Now let's go fdisk. Fdisk is a command that's going to show you all the storage devices on your system. Let's go ahead and hit enter here. And let's do sudo fdisk. Didn't like my fdisk as it was. All right. Here we go. So it shows me the disk SDA, okay, dev SDA. We saw that. It's 80 gigs. Tells me how many bytes, how many sectors. The disk model, it's a virtual box hard disk. Tells me the sectors are 512 bytes and lots of other information. But the key that we really want here is this here. Here's the SDA1, SDA2, SDA3, all right, SDA5. 3 partitions, the starting and ending block, how many sectors it has, the size, the ID, and the type. All right. Then we have SDB. This is my flash drive. It says 230.59 gigabytes. All right. It's a 256. It shows me it's a USB 3. It shows me the bytes and the sectors on it. All right. And then it shows me that there's a partition on that flash drive. It tells me the type is HPFS, NTFS, or exFAT. Okay, so that kind of gives you a basic understanding of how Linux denotes your storage devices. And once you know that, then you can begin to work with them, like we did with the DD command. Also, we have one of the things to keep in mind is that in Linux, we can mount devices, right? We can mount devices and unmount devices. Now, once again, let's go back to our top of our file system. Let's clear, all right? And then let's do ls-l, ls-l. Notice that right here we have a directory called mount. And this is where hard drives that are attached to the file system get mounted. A mounting basically just means it's available to the system. So it has to be attached and then available to the system at the mount directory. Now, most Linux distributions now do this automatically, very similar to what your Windows system or your Mac system does. But sometimes you may have to do it manually, and so we're going to take a look at that. Also note that over here we have a media directory. Media is where your flash drives and other devices are mounted. This is kind of relatively new within the family of Linux systems. So mount is used for hard drives, and then media is used for things like flash drives and other external devices. So let's go ahead and take a look at CD to media and see if anything is mounted there. So we can go ls-l. And you can see that there is right now, looks like a CD-ROM, okay, is mounted there. And let's go back and take a look at the mount directory and see if there's anything mounted there. It looks like nothing is mounted there. Now, if we wanted to go ahead and mount something, we can use the mount command and go mount, all right, and say we wanted to go ahead and mount device. Let's go device and say we want to mount that flash drive, and that was SDB1. And where do we want to go ahead and mount it at? Well, we could mount it at the MNT. Let's go ahead and hit enter. And it says must be super user to mount, of course. So we're going to go ahead and use sudo mount dev. This would be trying to mount the flash drive. If it didn't automatically mount itself, we can go ahead and mount it. And it looks like the disk contains an unclean file system. The file wasn't safely closed on Windows. It's fixing it. So right now it's been attached to the Windows system. When it was disconnected from the Windows system, it left some remnants there. It wasn't safely removed. So it's going ahead and fixing that, and then it'll go ahead and mount it. Should take a few minutes. It's a good idea. I think what happened is that when I didn't eject it, I just simply took it out. And I went ahead and mounted it. All right. Good job. If I want to go ahead and unmount it, I just use the U mount, not unmount, but U mount dev SB, in this case SB SDB1, that's what we had mounted. Let's go ahead and U mount it. And no such file or directory. Let's use a sudo U mount and dev SDB DB1. There we go. Now it's unmounted. I must have made a typo previously. Let's see if I did. No, I think it just, when I typed it originally, I didn't use the sudo, so it just kind of gave me that error message. Okay. Now, when we're monitoring file systems, we have another command that we used a little earlier, and that's called df. Right? Df just simply allows us to look at what's available spaces. df stands for disk free, and we can go ahead and see all of our devices and see how much capacity they have. That's always useful to know. So it says right here that device SATA device, the first one, partition one, shows us how many blocks it has, how many are used, how many are available, and the percentage that's used. Sometimes we have to go ahead and check for errors, all right? And we have a command called fs check that can check for errors on the device. It says command not found, use sudo fs check. All right, so what comes back and says it's mounted, all right? So it's not going to allow me to go ahead and do any checking because it's mounted. So I'd have to unmount it. And if I unmount it, then my operating system is not going to work. So this is only going to work when you can unmount the device and then go ahead and check. Now let's see. I've got a flash drive in here. Let's go and let's see if I can go ahead and do a FS check on it. Unmounted. That's that unmounted SDB1. Let's see if I can go ahead and do a check on that one. FS check, and then we can use the -P, right? And then dev SDB1. That would be my flash drive here, and I should be able to. Once again, I got to use sudo before it. Tells me it hasn't been found. And no such file or directory trying to open SDB1. Possibly non-existent device. Let's try it without the partition. Still doesn't. Let's make sure that my flash drive, when it got unmounted, remounted itself to the Windows system. Let's see if we can do this in a VirtualBox system. What I want is to go USB, PNY. There it is, but it is mounted now, so that's going to create problems. No, there we go. Okay. All right, it says bad magic number for superblock while trying to open. The superblock could not be read, does not describe a valid ext, extended 2, extended 3, extended 4 file system. If the device is valid and it really contains, okay, so it's only going to work, as it says here, for extended 2, extended 3, and extended 4 file systems. That particular flash drive is an NTFS, right, and exFAT. So it's not going to be able to go ahead and do any file system check. It also tells us more, okay? If the device is valid and it really contains an extended 2, extended 3, extended 4 file system, okay, then the superblock is corrupt. You might try running the extended 2 FS check with the alternate superblock, okay, the superblock number and device. It found a DOS partition table, all right, so it's telling me that it's probably for a Windows system, and that's the problem. All right, but it can go ahead and remove, kind of like I'm trying to remember. I haven't used this in a long time on Windows. File system check. Is that what it is in Windows? So you can do the same thing. If there's any bad files, corrupted files, it goes ahead and fixes them. So that's chapter 10 in Linux Basics for Hackers. Let's move on to chapter 11. Okay, let's take a look at Chapter 11, which is on the logging system. Okay, for any Linux users, it's crucial to be knowledgeable in the use of the log files. In other words, if you're an administrator, you want to know what's been taking place on your system. Okay, the log files store all the information about everything that's been going on in the system, including errors and intrusions, things that have gone wrong, people that have logged in, all that's going to be in the log files. As a hacker, though, the log files can be a trail to your activities and identity. So, one of the things we want to do is be able to see where the logs are kept and then maybe how we can manipulate them to hide our identity and our activities on the system. In most Linux systems now, we have what's called the rsyslog system, the rsyslog daemon. So this is a process, okay, a daemon that runs in the background that manages all of the logging on the system. Now let's take a look at the rsyslog daemon. So we can simply go locate and go rsyslog. Well, things are not typing on my system. I have to go ahead and change the focus. Rsyslog. You can see there's a whole lot of files. Okay, and if we go right up to the top, we can see that there's an etc rsyslog conf. That's the configuration file for rsyslog. Rsyslog is the logging daemon for our system. Now let's go ahead and open up that file. Let's go sudo mousepad and take a look at the configuration file for rsyslog. It's going to be at etc rsyslog syslog.conf. Let's see, spelled it wrong. Okay, let's go back. Make sure I get the rsyslog dot. Forgot the F at the end. There we go. Okay, so here's our rsyslog.conf. You can see that it's using port 514. So remember, port 515 for rsyslog on Linux systems. If port 514 is open, it means that it's sending its logs out to a syslog centralized server. So let's take a look at let's go down scroll down this file a little bit. You can see it talks about the file owner, the file group, okay, the file creation, and the file create mode. All right, so this is directory create, and this is the file create mode. Those are the masks we learned about, I think, in chapter 5. Got some standard log files. You can see them here. Here's the mail logging files. You can see here the daemon, the cron, the printer, the mail, and the user. All right. So these are all the logging directories. It tells you where you can find those directories, where you can find those logs. Now, the logging system is based upon this idea of a facility, a priority, and an action. Okay, facility, a priority, and action. So for instance, here's the logging for mail. Mail is the facility. Let me just put this up on the screen before we move in here and go. The logs are kept by a facility, okay, dot, and then the priority, and then the action. So in the case in this logging file, you can see for mail, all right, that's the facility. The priority is info. That's a low priority. And then where will you find those at? And then you have mail, the facility, a warning, which is a little higher, and where you'll find those logs. And then mail, and then error, which is a slightly higher priority, and then the var log mail errors where you'll find those at. All right. So the list of the priorities look like this. So we have at the very bottom, we have debug, then we have info, then we have notice, then we have warning, then we have error and error, both. So those are the priorities. And then each one of the facilities, you can see those up above here. The facilities are going to be auth or auth priv. Okay, these are security authorization messages are going to be in here. The cron is going to be the clock daemons for managing jobs. We have the daemon, there's other daemons. So when it has the star after it like that, that means all. Okay, all priorities are all going to go there unless it's otherwise spelled out. Then we have the kernel messages, the printing system, the mail system, and the user. I guess I didn't give you all of the, I must have missed some of the priorities. Let's get them all down there for you. There's also critical, and alert, and emergency, and panic. That sounds pretty serious, right? So the codes warn, error, and panic have all been deprecated and should not be used. All right, but deprecated means that usually they'll work, but they're preferred that you use the. In the case of error, it would be ERR. In the case of panic, it would be alert or emergency. So, for instance, let's go back to our configuration file. Where is it again? Let's go open it up. So we talked about here that mail, all right, all the mail for all priorities is going to go var log mail log. You can see the pattern here. That's going to be var log and then the facility and then with an extension of log. Now we can see here that we can separate out the mail, different mail messages, and each one of those, okay, uses the priority level as the extension. So we could go ahead and, for instance, and it shows you more log files, but say we wanted to go ahead and create, let's say, what do we want to do here? Let's go, say, for kern. This would be kernel messages, okay? Kernel in the critical kernel messages. And then we want to go ahead and put those into, let's tab across and go var log and then kernel. Okay, so we can put in any directory we want. We could end it with kernel log. Okay, put an extension log. We don't have to go like that. And now all the critical kernel messages are going to go into that directory. All right. So that's how the logging file works. Let's go ahead and close it down now. Now that you know how it works, let's don't save it. I don't want to change it, make any changes. Now there's another file, okay, called log rotate. Let's go ahead and take a look at that one. Log rotate determines how often the logs get essentially rotated, meaning they're overwritten. Let's go sudo mousepad etc log rotate.conf. All right, and here's the default settings. It says C, first line is a comment, says C man log rotate for details. Okay, and you can see here that the log files are rotate log files weekly, keep 4 weeks worth of backlogs, rotate 4. Create new empty log files after rotating old ones. That's just the keyword is create. Use date as a suffix. Okay, so here's commented out, so it's not using it. Uncomment this if you want your log files compressed. So we don't want them compressed. And then packages drop log rotation information in this directory. Include etc log rotate d. All right. Now, one of the things that we might want to do, all right, is to go ahead and have the log files rotated out more often, right, so that it's not maintaining logs for very long. So we could go ahead to, if we're trying to be stealthy on this system, we could like rotate out every week and do a daily rotate. All right. So it's only going to keep, okay? Rotate the logs out daily and keep 4 weeks worth of backlog, so we can go ahead and actually we could just make it even simpler, and that would be simpler to go ahead and comment this out, right? And so it's going to just rotate logs on a daily basis. And so next day they're going to start overwriting, meaning the evidence is going to be removed almost, it was in 24 hours. Making our activities, there'd be no, so once we're inside the system, if we're inside this Linux system, either as an insider or as a hacker who's gotten inside, we can go ahead and start trying to cover our tracks by manipulating the log system, okay? Taking away, making sure no evidence is left behind. Let's go ahead and then close this, and let's not save it. Now, one of the things we could do even more effective is when we come into a system is simply turn off logging, right? So we could go do sudo, all right? And this is where things are a little bit different than in the textbook, okay? In Linux Basics for Hackers, so shouldn't call it a textbook, is that we should use the system control, right? Sudo system control, and then our syslog stop. What this does is it stops the logging system entirely. So if we have just hacked into the system, now we can go ahead and turn off the logging so that there's no evidence left behind. Let's go ahead and do that. Unknown command, rsyslog. Is it rsyslog D? I think is what it is. Let's see. Unknown verb. Oh, I got it in the wrong order. That's the problem. Let's go. It should be stop. Stop. rsyslog like that. Stopping rsyslog, but can still be activated by syslog socket. Okay. So now there's no logging taking place. So all of our activities now are not going to show any activity. And it's going to be very, very hard to determine what we're doing, okay, or if we're even in there. Let's go ahead and look at the contents of some of the log files. So let's go say var log. These are the ones that are already in there because we just turned off logging. And these are the authorization log. Let's see what we have there. And let's put in a star to get all of them. All right, you can see there's a few of them here. Some of them have been compressed. You can see they're gzipped here. There's others here. Now let's go ahead and say more var log or var. Let's see what's inside these auth log. Tells me permissions denied. I need sudo. All right, only the root user has access to those. And you can see there's a whole lot in these files. All right. See system open, session open for root. All right. These are all the, this is a very small percentage of all the open and closed by root. And this would probably what we'd want to do. Let's go ahead and do Control C, or I'm sorry, Q to get out. Let's try using tail. Remember we learned the tail command? Let's go tail -20 and the same file. We're going to need to use sudo on this as well. This will just show us the last 20 lines, which is really what's most important to us. Var log. These are the authorization logs, right? Option used in invalid content. Let's see. Take off the. There we go. I was asking for multiple files to tail. You can't do multiple files. I was using the wildcard. And you can see here's a Kali logging in. You can see Kali, and then all the uses of sudo by Kali. These are all being logged by the rsyslog. Not anymore because we've disabled it now. But what if we wanted to get rid of these as well, right? So one of the things we could do is to go ahead and shred these. And there's a command in Linux called shred. Let's go ahead and clear our screen here. Clear. I don't know why my fingers always want to type it wrong. There's a command called shred. Let's go, not Shrek, but shred. Let's go look at the help screen for shred. What shred does is it goes ahead and takes a file and overwrites it multiple times so that it cannot be recovered. So what we could do is to take that file and write over it, and let's go and try it. So sudo shred. So if we delete a file, if you try to delete a file, it's still there for a forensic investigator can still find a deleted file. Shred, though, overwrites the file, so it cannot be recovered. So shred, we're going to do a force-n, okay, 10 times, this one, overwrite it 10 times to the var log auth log. Let's get that dot in there, dot log. And let's go ahead and now, if we go ahead and say tail, our tail command to read that file, let's take a look at what it shows now. You can see that everything, nearly everything, some of it's still there, and so surprisingly, nearly everything has been shredded. Let's try shredding again. Force 10 times over, and then let's look at it again. There, got most of it shredded. For some reason, there's parts of it that are not. Might have to keep on doing it to get rid of all of it. So that kind of covers up our evidence that we've been there. All right. So that's logging. We learned a little bit about what goes on in a normal system, all right, and then how we can go ahead and cover our tracks if we've hacked into a Linux system and don't want to leave any evidence behind. So let's move on now to chapter 12, which is using and abusing services in Linux.